Chapter 16, Example 4. A new sales gimmick has 30 of the M&Ms in a regular bag covered with speckles. These candies are mixed randomly with the normal candies as they are put in the bags for distribution and sale. You buy a bag and remove candies one at a time looking for the speckles. Is this a Bernoulli trial? Provide support for your answer. So each M&M is speckled or not. So there are two outcomes. And the probability of a speckled M&M remains the same. Trials are independent as one bag of M&Ms should not affect another bag. What is the probability that the first speckled M&M you see is the fourth candy you select? So the probability of the first speckled candy is the fourth. This is a geometric probability, so we're going to have 0.3 to the first times 0.7 cubed, which equals 0.1029. The 0.73 cubed is the first three ones missed, and the 0.3 to the first is the fourth one being speckled. We can also do this with technology. So with technology, we would have geometric PDF 0.3, comma 4. And we'll show you how to type that in. So from our calculator menu, we go Menu, Probability, Distributions. We want geometric, so geometric PDF. Probability of success is 0.3. We want it on the fourth M&M, so we put 4 in. And okay, there you go, we get the same answer. What is the probability that the first speckled one is the 10th selected? So this is very similar to what we just did. The probability of the first speckled is the 10th will equal 0.3 to the first, because that's our getting that one success, times 0.7 to the 9th, because first we have 9 that are not speckled, and that equals 0.0121. Once again, we can use technology to do this. We would do geometric or geom PDF 0.3, comma 10. So a probability of 0.3, 10th candy. Type in the calculator, calculate page. We're going to hit Menu, Probability, Distributions. Go to Geometric PDF. Just like in the last one, now we're going to do 0.3 and then 10. And there you go, the same value that we just had. What is the probability the first speckled one is of the first 3 we look at? Okay, so now this is a little tricky. We're finding the probability of the first speckled in the first 3. So the best way to do this is the probability of a speckled not in one of the first three. So the probability of not getting speckled in the first three is 0.7 cubed, so it's 1 minus 0.7 cubed, which equals 0.657. On average, how many do we expect to have to check to find a speckled one? So this is our expected value. Mu equals 1 over the probability of a speckle, so 1 over 0.3, which equals 3.33. So on average, we would expect to find a speckled one, M&M, on the third or fourth try. What is the probability that we will find 2 speckled candies in a handful of 5? So now this is going to be a binomial because we're saying 2 out of 5. So out of these 5. So the probability of x equals 2 will equal 5 choose 2 times the probability of the 2 speckled, so 0.3 squared, times the 3 non-speckled, 0.7 cubed. This equals 0.3087. We can also do this with technology. What is the probability we will find 2 speckled candies in a handful of 10? Again, this is binomial, 2 out of 10. So P of x equals 2 equals 10 choose 2 times 0.3 squared, because we still want 2. So it's 2 successes, 0.3 squared. And now we're going to have 8 failures, 8 non-speckled, 0.7 to the 8th. This equals 0.23347. Okay, what is the probability that we will find at least 3 speckled candies from a selection of 8? This is where it gets tricky. The probability that x is greater than 2 equals 1 minus the probability that x is less than 3. This is a lot easier because then we just have to calculate 0, 1, and 2. If we did greater than 2, we'd have to do 3, 4, 5, 6, 7, 8. So it's 1 minus 8 choose 0 times 0.3 to the 0, because we're getting no speckled here, times 0.7 to the 8th, because they're all not speckled, so there's 8 out of 8, plus the probability of getting just 1 speckled. So 8 choose 1 times 0.3 to the first, because I'm getting 1 speckled, times 0.7 to the 7th, plus 8 choose 2 times 0.3 squared, times 0.7 to the 6th. Again, that represents 2 speckled and 6 not speckled. This equals 0.4482. So with technology, we're going to go to calculator page, probability, distributions, binomial CDF, and this is going to be a lot easier than what we just typed in there. So we're going to do 8 trials, probability of success is 0.3, lower bound is 3, because we want to have at least 3 speckled, upper bound is 8 because it's out of 8, and 0.4482, just what we calculated by hand.